Hello everyone, welcome back to System Shogun. Today I'm going to show you a multi-agent solution that takes an image of a damaged car, processes it using events and agents as a containers, and at the end we have a summary of what the car is, some details about the damage, as well as the cost of repair. So right now, here's the diagram that shows the solution. So we have some inspection camera that takes an image, takes a picture of a damaged car, for example. We store that image inside the Blob Storage. We create an event using event grid topics, and then using Azure Service Bus, we create 3 topics. And the first agent that acts on the file upload is the vision agent worker, which downloads the image from Blob Storage, analyzes the damages, as well as some metadata about the image, like the brand, the car, what the model is, the year, using Microsoft Foundry, and then it stores the output inside its own database using Postgres. Once the vision agent is done, it sends a message to the vision analysis completed topic, where the next agent, cost estimation agent, is subscribed. And what the cost estimation agent does is, based on the vision agent output, it uses the pricing catalog, which is a synthetic data that I created for this solution. And it uses AI Search for performing a RAG. And using AI, it performs some cost estimation, which then it outputs to its own database. Once the cost estimation agent is done, it sends a message to cost estimation completed topic, where we have a third agent, summary agent, that basically does what the name suggests. It summarizes the output of the previous agent inside, it stores it inside Postgres again. And then we have a summary agent API container that is responsible for querying that database. So I didn't want to allow anyone to connect to the agent. I wanted to have some abstraction, and that's why I created the API. And then we have the web container, which is a Blazor WebAssembly solution, which provides some UI that I'm going to show you in a bit. And that's the solution. For all of that, I'm also using the outbox pattern, and I'm going to show it to you in a bit. But what the outbox pattern does is it allows us to make our system more reliable, because otherwise, what happens if, for example, I store the output of the agent inside the database, but then this thing right here, sending the event to the topic, fails for some reason. It could be any reason. Issues with our container, with our solution, or anything around networking, whatever it is, it could fail. So these two are 2 different processes that need to happen. And for that, we're using the outbox pattern, which basically stores the output of the agent, as well as an output inside another table called outbox, which table contains the payload for the event that we want to send. And then we have a sub process that queries that table and sends the messages to the service bus topic. So we have decoupling, and this makes our system way more reliable, because even if we cannot connect to the service bus for some reason for a day or 2 or whatever time frame, we have the event stored inside our database. So at one point, whenever that might be, whenever the service bus starts working again, we have the event stored, so this worker will eventually be able to publish that event, and the flow will continue. So that makes our system way more reliable. Now let's take a look at the Aspire dashboard. And here's the Aspire dashboard. As you can see, we have the AI search here. We have Azure Service Bus, for which I'm using the emulator, not the real one. We have storage account, which is again an emulator. I'm using Azure. We have the Postgres database. We have the API and each agent as well. So cost estimation agent, summary agent, vision agent. We have the web application here, as well as the migrations, which basically executes our migrations automatically whenever I run the application. So that's the dashboard. It's really powerful solution. Aspire, I really love it. Now I can easily deploy this solution to Azure. But now let's take a look at the solution itself, the interesting thing here. Let's open the web application, and here's the application. So we have a really basic UI where we can upload an image of a damaged car. So let's choose one. For example, I'll upload this image right here. Let's take a look at it. So this is a damaged BMW. Let's select it and click upload. And since this is asynchronous, I can go to the view results, and right now there will be no results, but it will refresh every 30 seconds. And let's take a look again at the solution and what we're doing at the moment. So right now I'm uploading an image to the Blob Storage. Then an event will happen, and it will store that event inside the inspection photo uploaded topic, where the subscribed vision agent will get triggered. It will download the image, and it will start scanning the image, extracting some useful information like what the brand, the model, the year is, and as well as the information about the damages that are being done to that vehicle. It uses Microsoft Foundry for that, and then it stores the output inside Postgres database. Once the vision agent is done, it sends an event to the vision analysis completed topic, where the next agent, cost estimation agent, starts. It gets the information of that event. It goes to the pricing catalog that I created. It's basically a synthetic data with pricing for different parts and different car brands and models. It uses AI Search, so it's using RAG. And then it's using AI as well to do this estimation. And it stores the output inside its own Postgres database. Once it's done, it sends a message to the cost estimation completed topic, or an event rather. And then the last agent, summary agent, basically summarizes the whole thing, and it stores the output inside its own database. Then we have the summary agent API that queries that database, and we have the web that you just saw, which queries not the agent itself, it's querying the API. Now let's go back and see the results that we got. And here are the results. So it correctly figured out that this is BMW 5 Series, the model range and the model years, the total estimated cost to repair, some description of the vehicle as well as the damages to it, and each part that is damaged, and some details about the pricing, the labor cost, and yeah, and that's it. Now let's quickly take a look at the outbox pattern that I just talked about. So here is the vision agent. As you can see here, we have two workers. One is the agent worker, which is the AI agent, and the other one is the outbox worker. The agent worker uses AI to analyze the image and then stores the output inside the agent table. But then we are also storing that output as an event message to the outbox table. The outbox worker queries that table, and whenever there are new messages, it pushes those messages to the topic that we just saw in the diagram. Let's quickly take a look at how this is achieved. So here's the agent worker. It's using this topic and this subscription. And whenever there's a new message or an event, it gets triggered, it downloads the image, it performs some AI analysis. So this is the core of what this agent does. It's using AI to analyze the image and the Then we add the agent output inside the DB context for this table, and we also add information about the event for the outbox table, and we store both of these as a transaction. And that's critical because we don't want to publish the event here, because like I said, this could be stored in the database, but the pushing to the service bus could fail, and then we have an inconsistent system. So now we only store the data and the outbox message, and that's it. Then we have another worker, outbox worker, that queries the outbox table for messages, and it sends an event to service bus. So even if the service bus is down or we don't have access to it or whatever, we can try again and again. This worker will try again and again because it already have the event stored in the database. And at some point, the event will get published eventually. So that makes our system extremely reliable. And that's the outbox pattern. Let's quickly take a look at the database. So we have 3 databases here: Cost Estimation Agent DB, Summary Agent DB, and Vision Agent DB. Let's take a look at the first the Vision Agent DB. Here, as you can see, let me close all of these. We have 2 tables: Agent Output, which contains information that the Vision Agent see what the data is. Here it is. So basic information about the vehicle as well as the defects that the AI found. Then we have the outbox message table, which basically stores the event that needs to be published, which contains data about the event that happened. Now let's take a look at the summary agent. So the summary agent doesn't really have anything inside its outbox table, but it could. It's just that at this point we don't have anything to store in there because we're not sending anything to any other system. So that's why we're only storing data inside the agent output table. Let's take a look at it. Here it is. And here basically is the data that you just saw in the UI. We have the make, year, brand, model. We have all the parts as well as the pricing for painting, for repair, for parts. And we have the year, we have the summary and the total at the end. And that's basically it, guys. I really hope you enjoyed this video. If you did, make sure to subscribe to the channel and like this video and maybe share it with your friends.